Welcome to CodingCraft. Today, we're tackling the classic stock span problem. It's a favorite in interviews and a perfect example of where brute force struggles, but a monotonic stack shines. We'll turn a slow O(n)² solution into a clean O(n) with one powerful trick. Let's break it down, step by step. Here's the problem. You're given an array of daily stock prices, and for each day, you need to calculate the stock span, that is, the number of consecutive days, including today, where the price was less than or equal to today's. We're working with up to 10,000 prices, and each one can be as high as 100,000. The output should be an array of the same length. Let's look at an example. With these prices, the final span is 6, because the price on day 7 is greater than or equal to the prices on all 6 previous days. Seems simple, but how would we actually compute this for every day? Let's try the naive way first. Let's take a closer look at the brute force solution. For each day, we scan backward through previous days while the price is less than or equal to today's, and we count how many of those days make up the span. This works, but it's slow. Each price might trigger several comparisons, like here, where calculating the span for 90 involves checking 75, 60, 70, and so on. That's fine for small arrays, but in the worst-case scenario, like a long stretch of increasing prices, each day ends up comparing with all previous days. That means nested loops, and with 100,000 prices, this can lead to billions of checks. So while it's easy to write, brute force just doesn't scale. There has to be a better way. Instead of scanning backward from each day, we switch to a smarter approach, the monotonic stack. We keep a stack of unresolved indices and walk through the array from left to right. If today's price is higher, we pop from the stack, resolving days with lower prices. The remaining top gives us the distance to the last higher price. Since each index is pushed and popped only once, this gives us an efficient O(n) solution. Below, you can see the stack evolving step by step, clean, linear, and fast. Here's our final Python solution using a monotonic stack. We loop through each day's price, keeping a stack of unresolved indices. For every new price, we pop all smaller or equal ones, then calculate the span using the last higher price to the left. The result? Each index is pushed and popped at most once, delivering clean O of n performance. Stock span solved smartly. Let's quickly recap. Brute force solutions can be slow, O(n)² in this case, but by using a monotonic stack, we skipped redundant comparisons and achieved clean O(n) time. Each span was computed in constant time, fast and efficient. What's next? We'll explore more classic problems solved with smarter strategies. Up next, remove k-digits. Check out our shorts on the next smaller element and subscribe for more clean visual solutions. Watch the next video to see this trick work again.